everybody to the Go Meetup. Well, I shouldn't say the Go Meetup because I run another adjacent Go Meetup. So to the Utah Go User Meetup, that's the better name for it. That's the official one. I'm Mariah. If you haven't met me before, I'm sorry. I'm Clint's replacement. Clint decided to go voting tonight, so I get to be in charge. And if you haven't met Clint, that's why, because I'm in charge. So thank you all for coming. I don't want to take up much of your time. I just wanted to say we do have a meetup scheduled for next month. If it doesn't say so, I apologize, but it is kind of a serverless Go type Slack bot thing on AWS. So if you're interested in Go, serverless, and applications of it, Slack bot is clearly the most useful application. So you should come learn about that. Most of our updates, if not every single one of our updates, is posted on one of these two forums by me, Twitter or Slack. This is the Forge Utah Slack. Forge Utah is the nonprofit that sponsors all meetups that happen at Weave. So that's Utah Go User Group, Cloud Native Utah, Machine Learning Utah, Front End Craftsmen, Women Who Go, and any other meetup that happens at Weave is sponsored by Forge Utah. So all of the information can be found on the Slack. I invite you to sign up because at some point I'm still going to start sending all the good stuff through there. So yeah, I'm going to turn the time over to our presenter tonight. It's Brian. He will introduce himself and get started. And thank you all for coming. You start with the run of, yeah?
Are you going to do the jobs thing? If people have jobs,
oh,
do that.
I always forget that. Sorry, I just forget. Does anybody have jobs or something? Yeah, we got a job with like, if not, you can post it to the Slack. We have a jobs channel. See, this is why I forget everything's on Slack. Yeah. But I do like to, please, go ahead.
Well, so I work for Verizon. He also does too. It's mostly a Python shop, but we've started introducing a little bit of Go. We're looking for a software developer in test. And I think Dustin said the level is like 3, yeah, SDET 3, level 3 or 4. Anyway, so
is that your team?
That yeah, it would be kind of our team. Yeah.
Okay, because yeah, and us too.
So yeah, if you're looking.
So 2 positions.
And so we're yeah,
4 or 5. Like still this team.
Maybe. So if you're looking, yeah, if you want to, but like I say, it's mostly a Python shop. We do video streaming for Verizon, and most of us work remotely, but the office is in Sandy. So.
Feel free to sign up on Slack and share your job postings. We have it's a bigger community. We love Go. Obviously, I will always be a Go proponent, but like I said, you can get more people.
Okay.
We do have a forum for that, which is why I always forget. Any other jobs or?
Cricket is hiring for all positions.
Cricket's hiring for all positions. I assume you can ask, what's your name?
Andrew.
Andrew for more information.
I'll jump on that Slack channel.
Perfect. That's amazing. I love it when people join Slack. Anything else? Okay.
I guess I work with Brian at Walmart Labs. We have.
Oh, you work at Walmart? Oh man, that's where everybody, except for Greg, he left.
We have, well, we got half a dozen Go programmer positions open.
Yeah, Walmart was the place that didn't hire me, so. Good for Weave, right? They're good. All the people I know that work at Walmart enjoy it, except for Greg who left for Reddit. But I think that was for other reasons, right, Greg? It was not because he didn't enjoy it.
Most definitely not.
Cool. Anything else? Okay, you can really have the floor now.
Okay, great. Yeah, cool. So hi, everyone. I'm Brian Merrell. I have been attending this Go meetup since day one. Since I moved to Utah County, I don't come as often, but it's good to see everyone here. I work for Walmart Labs on Go network infrastructure, mostly involving like proxies and edge computing, CDN type stuff, content optimization, things like that. So I guess I'll just hop right into my slides, kind of dovetail with my introduction, I think. So. We just have to do this in non-presentation mode. It's good to, I don't know. Anyway, okay, so story time. I worked for Walmart Labs for 3 out of the last 4 years. I worked for them for almost 2 years, and I took a year break to work at Western Digital doing SSD architecture things. And then went back to Walmart. The reason that is important is because when I started at Walmart, we were a really small team. We were like 4 engineers. Everyone kind of had their own systems up and had their own development environment set up for the things that they worked on, and it was totally fine because it was just 4 people. Everyone had kind of been there for a while and gotten their machines in the state that they'd wanted them to be in, and it was all, everyone was happy. When I left and came back, the team grew from like 4 engineers to more like 30 engineers. And one thing I noticed when I came back was that still everyone was just kind of doing their own thing development-wise, except for it didn't really scale that much because there was new product features going in, new products, new services popping up that interacted, but only some people had some of the systems, and some people, we used MySQL, some people had like, everyone had a different MySQL version, some people were using like MariaDB, and their configs were all different, and it didn't really resemble prod, so just because something worked on their machine in dev didn't really mean it was prod. And I think that's a pretty common issue in companies, that just people kind of just have their own dev environments, and they use their own tools, and it takes a while to spin up. They get the state, and if their computer crashes, they're kind of hosed because they've got to like go and get everything back up. So when I started, Walmart was growing a lot. It was still, they hired me back. They were hiring more people. It was growing. Lots of new people, lots of new faces every month, and it seemed like such a waste that kind of everyone was off in their corner doing like whatever they wanted to on their dev machines and trying to get things cobbled together. But with that said, I'm like a firm believer that people should use whatever tools, whatever editors, whatever they're comfortable with. And so I was trying to think of like a really lightweight way to set up a dev environment. In fact, this all started actually just to set it up for myself, because I was given to start out a MacBook on Mac OS, but none of our software runs in Mac at all, so I needed some sort of Linux machine on there. So I started using Docker, started looking into Docker desktop for Mac. So that's kind of how this worked, and then I basically set up my own personal development environment using some Docker tools, and kind of showed a couple of other people like, hey, what do you think of this? You think this is interesting? And that kind of snowballed, and now a good chunk of the developers on our team, our larger team of like, now we're up to like close to 40 engineers, I think, 30 something engineers, where a lot of them are using this solution. So I want to talk about all those details about what I did, why I like it, maybe some trade-offs, and this will be a really demo-heavy presentation. Like I have a few slides here, but what I want to do is just open up, show the tools, answer any questions, conversation about. This is my first time giving this presentation and showing other people outside of Walmart what I've done, so it'd be good to get feedback and hear questions and things like that too. So feel free to interject anytime. But before we continue, I think it'll be helpful to kind of show what we work on at Walmart Labs, because I'm going to be showing my development environment, including all of these services, how they interact. Show some, in the demo, I'll show some tests of how things work. So basically, I work on a service called ODND, stands for Optimized Distribution Network Daemon, I guess. I often refer to it as a reverse proxy of doom because it's very like fundamental layer. It's a reverse proxy. It takes in requests from a client, sends them to a backend, gets the response back, and sends them. But it's doing a ton more than that. So this is kind of just a small list of everything we do. There's plugin execution, which is one of the huge things we do, where we expose Lua or Go plugins for users to write. When I say users, I'm talking about like our backend, like applications within Walmart are basically our customers. And so they can go in and write plugins, and we expose to them the request and response objects, and they can do things like add, delete headers, add cookies, filter traffic. The information security team has a plugin that blacklists like known bot networks, things like that. So it's basically, it sits kind of on the edge of Walmart's infrastructure. Like we're basically the first thing you hit that's a custom software service inside once you get inside Walmart's infrastructure. So we do a whole bunch of different things, asset verification for like PCI reasons, like personal credit card information reasons. We have retries, adaptive retries to the back end. We cache content, which is a big thing. Anyways, there's a whole bunch of this stuff, and people can set up different types of web backends. Like the most common is just a www config, which is just we make it HTTP request to the backend. So with all that said, on this right side, up at the top right, we also have a UI, a web UI portal you can go into, log in, configure all of these things that I was just talking about, and it sends a CDB, constant database, to the service every so often to sync out all these configurations. We have like 400 plus nodes. So once the configurations are made in the UI, they all kind of sync out to our service. So, and again, we are hiring, so if any of this sounds interesting to work on, we need lots of help. Shameless plug. Okay, so with that said, kind of give you some context into what I was dealing with to set up a development environment. Of course, like all of these things are different services talking to each other and interacting. MySQL, CDBGen, the front end, which we call admin D, the UI, that is, and then the ODND service. All of those things are at the back end. All those things are talking to each other. So I was trying to think of how I could use, I was trying to think of if Docker could be a good fit for a development environment. So I focus mostly on like software development. I enjoy like ops and those sorts of things, but my role is mostly writing software. So I was kind of looking into this as a software developer, can I leverage Docker for this setting up a development? So I hadn't used a lot of Docker before, so I was kind of learning about these things, but just to kind of, assuming Docker's becoming more and more prevalent, obviously, but just a quick review. When we're dealing with Docker, we're talking about images and containers. So the image is the executable package that includes all the things that you need to run an application, code, runtime, library, configuration files. So it's kind of like the meta, right? And then you create an instance of that image, which is a container. And so containers are runtime instance of the image, and that's what goes into memory and executes. It's more ephemeral, and you can remove it, and you still have your kind of your fundamental image there that you can create more instances of, etc. So I also wanted to point out that one of the things that I know tools like Vagrant. Is anyone using Vagrant for like dev solution? Okay. So I had used a little bit of that in the past, and it always seemed a little heavyweight. I mean, Vagrant is going to spin up like and manage actual virtual machines, which may be the right fit for you. But again, going back to like as a software developer, I think lots of times we like want these sorts of things to not get in the way as much as possible. So I like that Docker was kind of more relatively lightweight, that it used the leverages and share the host kernel, which is sort of true. And for Mac OS and Docker desktop, it actually is running a hypervisor. That's kind of may become interesting later on, but basically in Mac OS, there's some knobs you might want to tweak to give your Docker system more memory and things like that that you don't have to do on Linux. That's basically what it comes down to. Or CPU, kind of like tweaking your VirtualBox settings. So just a quick Docker overview. Let's see. So on this machine, I have, everyone see that? Okay, I can go bigger, actually. So on this machine, I have some images already. That's interesting. Okay, so I'm going to be using these just these TB Go images for this example right now. It's just TB is short for Torbit, which is the name of our kind of creator team. These are just simple Docker images with Go installed. So for Docker, you can just obviously do something like this, where you're.
The reason you use your own instead of just the upstream, or is this the upstream plus something?
Yes. Good question.
It's usually the upstream plus something. We have our own because we're like Go and Glide, because otherwise we install Glide in every single.
We use a forked version of Go, but only for some very, very small changes that we need for
That
certain
will hopefully
reasons.
be fixed and go to, but probably won't.
Okay.
Specifically, we care about the order that headers come in to us. And in Go, by default, headers are just put into a map, and you don't know which order they came from. So that's actually what we use. So anyway, you can spin up a. Well, I don't know how obvious is it. How many have used Docker just a little bit? Like, okay, so I think I don't want to assume that everyone's used it at this point, but what I'm doing here is I'm creating an instance of this Docker image, which will spin up an actual container into memory and start executing. So it's running. It's quick. I've got my own Docker system here, and
So good practice to get into there as well as for those who don't know, is use the --rm. So you're going to do a lot of runs like that one off. Otherwise, you'll end up
with your containers.
We've all been there,
Yeah, if you're on a PS, you're not going to see anything.
right? And
Do
then
the PSA.
until suddenly it takes you 10 minutes to run a PS.
Yeah, so is it? I always just run PSA and delete a manual, but you're saying I just run.
--rm when you do the Docker run. Docker run --rm -it or ti.
That tells Docker
You're
to
backward.
delete it. So, but just remember, as soon as you close it, it's gone.
Yeah, it will just poof the moment you're done with it.
That's totally.
But it's very, very useful if you're going to alias like CLI to run inside Docker, because then it cleans up after.
So now I've got 2 Docker containers running. They have their own IPs. So this is like basic, like Docker 101. This is how you spin up a container. I've kind of cheated because prior to this demo, the one thing I did do was build all of my images, which we can go over later. But they're all the images are built, which basically means I pulled down the data from the Docker servers or Ubuntu or all that stuff. So I just didn't want to have to show that because, especially for this stuff, it takes quite a while. There's a lot of images. I'll show you a little bit. But the point that I'm trying to illustrate here is we've got a couple of systems. I can take this IP, I can ping it from this other machine, but I don't really have any. They're not really made in such a way that they can talk to each other like out of the box like this. Like the host name doesn't resolve. I could go and I could set up my own user-defined network. We can talk to each other. I could do volumes to share data. But that's not really necessary for this because the Docker team has already created a really good abstraction for all of that stuff that's made for making services talk to each other, containers talk to each other. So the tool that I came across when I was trying to learn about the best way to leverage Docker for a development environment was DockerCompose. Who's used DockerCompose? Okay, cool. So quite a few people. So maybe if you guys, maybe this will be nothing new and this is stuff you guys are already doing. That's great. Maybe we can learn from each other what we're doing that works versus doesn't work. For those of you who haven't used DockerCompose, hopefully this will be informative for what it is and how it works, and why I think it's a good fit for a development environment. So this is kind of some bullet items. Most of them are lifted directly from the DockerCompose introduction site. I guess a couple of them. So the way they describe it is a tool for defining and running multi-container Docker images. So implicit in that is multi-container, meaning that you want these containers to talk to each other. And I've really enjoyed using DockerCompose. I think it has a lot of really nice abstractions for using Docker containers that need to interact in various ways. And then their list of common use cases are all of these things. I italicized development there because that's what I'm using it for. We're starting to find interesting ways and think about interesting ways we can also use it for testing and running local integration tests. I can kind of talk about some of our plans for that. Basically, DockerCompose leverages Docker files and adds this new layer on top of them to manage and help them communicate and do various other abstractions for them. So simple DockerCompose usage. So I've got jumping back here. So you're saying I'll still see that. Yeah, so that one went away, but I need to Docker. Oops. All right, so okay, so I've just got a little, this actually lifted completely. I was hoping to come up with a Go one just because it seemed more appropriate, but I didn't have time. This is an example just lifted right from the DockerCompose intro site. It uses a simple Python app, which is totally fine. This presentation isn't specifically Go related other than we use Go at Walmart for all those services I was showing you, so you'll see that. And Docker's written in Go for the most part. So, but otherwise, whatever language you happen to be using, or using multiple languages, this should work for all that. So I can just show you quickly. This is just a quick Python app. I don't expect anyone to be familiar with Python other than the Verizon guys that have already said that they're using it. But it's just using a simple Flask Python web server that talks to another Redis service container that's going to be managed by DockerCompose, and it increases. Every time you reload the page, it increases the Redis number and reads it out. So, the Docker file here, you'll see it grabs Python, set some environment variables needed to run Flask, I guess. Copies this requirements.txt. This is just Python specific. This is pip. Pip is Python package manager thing, and it takes a requirements.txt package to download any dependencies, and then it runs Flask run to start the web service. You may remember that I mentioned Redis. So you're like, well, there's a Redis Docker file. It's not necessary because in DockerCompose, you can actually specify the image right there in the DockerCompose file. If it's a simple image, you just put it right in there, and then like I said, it's an abstraction. It knows it'll do whatever magic on the back end to make sure that it builds that Docker image and runs the container. So setting up port 5000 there. So what I should be able to do now is, I ran this once yesterday, but this goes up. What DockerCompose up does is read through the DockerCompose file here and does the things that are specified in that file. You can, I was just trying to look and see what options you have here. I think you can, there is an option for pointing to a different path or a different DockerCompose YAML file, but by default it just uses DockerCompose. It's right there in your current working directory. So you can DockerCompose up that. It's going to be building those images, since I didn't actually build these ones in advance. I built the related ones. So this is kind of what's involved in building the image. It's pulling all the software dependencies, all that stuff. But then after it's done building, it'll go on to running the container. So it will come up. Those services will come up, and it will start logging the output from those services.
Question over here.
Oh, yeah.
A while back when I was using DockerCompose, you had to specify build. So DockerCompose up build. Is that no longer necessary?
It does it automatically in the up now.
Okay,
Yeah, they've streamlined a bunch.
gotcha. So does it build if there isn't an image?
So it'll only build if there isn't an image. So if you need
Okay.
to rebuild, that's what that dash build flag was for, was
Gotcha.
fourth rebuild. But yeah, so
Okay,
this is the first time it's like, I don't even have this
yeah,
build.
gotcha.
You're right.
Okay,
It still is, if you make a change,
you would still need to specify that, okay.
yeah.
Yeah, okay. So what I should be able to do now is go to and you notice that the server is not running on my machine, but it's running inside that container, which has its own IP. But the way that the I think it was the Docker file in this case was set up, it's finding that port on my host also. So you send the request to the host, it forwards it onto the container.
DockerCompose YAML is where that was specified.
Well, is that right?
The 5000.
Yeah. Okay, yeah, thanks. That's where okay.
There's some cool things to note about this, in that DockerCompose doesn't do anything you can't do with Docker itself. It is just a way to build a bunch of API commands to Docker. It has no functionality in and of itself. So you could convert exactly what you see in that YAML to a couple Docker commands and it would work, or your own API calls. Like it's really handy, but it's important to know you don't have to write things that call the binary to try to do this stuff. If you want to automate it, you can automate it directly with the API. Also, DockerCompose has some potentially undesirable default behaviors, in that if you define ephemeral volumes in your Docker image, in your Docker image, you can go say volumes, and you kind of give hints that this image might put data in several places. DockerCompose will go ahead and just make those volumes for you, whether you ask it to or not. And that can be really just if there are plenty of cases you'll find where the Docker image, when you run it yourself, works fine. You bring it up Compose, you delete it, you bring it up again, and the data didn't disappear like you expected it to, because DockerCompose helpfully said, oh, the image told me it needs a data file here, so I'm going to make that directory and mount it. And so you got to be kind of careful when you use Compose, because it will do some secrety things under the hood.
Yeah, that's specifically about volumes. They advertise as a feature to manage their volumes, but we use it, but
Well,
hopefully-
explicitly putting them in is one thing, right? Like imagine if you use the MySQL image and you don't specify any volumes, it will automatically make a Docker volume for varlib MySQL, and then you'll do a DockerCompose down, and you bring it back, and then bring it back up. So you deleted the image and brought it back up. You didn't specify anywhere in your compose file that you wanted to mount the data directory to your system. But the data doesn't disappear. Like it does some implicit weird, anyway, it's not a big deal. It's just, if something's not behaving right in DockerCompose, it might be default behavior.
okay. So anyway, refreshing the service, you'll see it, you synchronize it. The Python web app container is talking to the REST container, doing that increment, and that's the basics of how DockerCompose works. So,
Also really cool, you don't have to specify the links anymore. In earlier versions, you had to explicitly say how the containers were linked to each other and what their names were.
oh, interesting.
Yeah,
That's all I did.
Web server linked to Redis with the name Redis.
Yeah, I think that switched when they made the name network. So now they just create the default network and whatever it is.
That's kind of nice. That's
Yeah, okay.
something different.
Okay, so that's how these two containers are talking to each other. It creates a network on the back end.
Yeah, yeah. And that's what I was saying, like with Docker, I could spin up both those images, but by default, there's extra work that you can put into it to be able to get them to resolve. And I mean, they could talk if you knew the IP ahead of time and all that stuff, but DockerCompose just builds these nice abstractions. Now I know this other service is running, I can talk to it directly.
You should actually go in, since he's asking, go in and do a Docker network.
Okay, so if you had other compose files, it's per compose file, I believe. If you wanted to opt in to having two compose files that knew about each other, you'd have to get them to point to the same existing network instead of creating them automatically.
Oops, I don't need to be in that directory.
So you have to do an LS and then it inspects. No, sorry, LS instead of suspect. Yeah, so you can see it made a compose test default network for you, and then if you inspect that, the containers that are currently a member of that. So it made a little virtual network for all of the things in that compose file. Put the containers in that virtual network and set up DNS by the container name automatically. So that's why the Flask app can just say, the host name for Redis is Redis, and it just goes to the active container.
Okay.
It's all kind of magic.
And so it broadcasts within each container where the names of the other ones are. So you just
Puts it in like a host
container
file,
by
actually.
name.
Yeah, I don't think it broadcasts. Yeah, it does some DNS. Either injects it in the host file or intercepts the DNS. And
You can check that out.
Yeah, you can jump in and see. It's either in the host file or it override, because it puts the DNS server itself in there.
yeah,
So it, as a DNS server, just like, oh, you're in this network, so if you ask for Redis, it's referring to this, and it'll respond with that IP address.
Yep, just popped it right there.
for the other.
Is that right?
No, that's
So
for
the container
itself.
name, that's itself. It,
Yeah.
it must be that it's just using its DNS result.
I think,
Yeah, so if you cat resolve conf, you'll probably see a weird IP. Like he said, the Docker daemon itself is acting as a DNS middleman.
yeah, this is making sense too, because I've seen, I can talk about a specific example later, but I haven't exactly figured out how the DNS works because I had to do a little bit of trickery to get one service to actually resolve to another. I don't remember the exact details, but the DNS is still a bit of a mystery to me.
I bet you the link command is what makes the host entries for sure. But by doing DNS stuff instead of linking, you can make the containers in any order rather than having to make one so you can know its IP to make the other. That'd be my assumption of why they've changed the behavior.
So anyway, you can see these logs. I was refreshing the browser there. Your web service is logging. It's getting GET requests, responding to 200. Obviously, if your services have different logging, you'll see that here. All those goodies. So just Control C. By default, Control C will stop the containers. So it's equivalent to running Docker stop on the container. And then to actually remove the images, you can run a DockerCompose down. If you're in the, if it sees that DockerCompose file, it knows what to bring down. It removes those images, removes the containers, sorry. And the images are still there. So you can see now there's not any Docker. They still do stick around here. No, those were there before. Never mind. Sorry. Okay, so that's kind of like the simplest DockerCompose example of the basics of how it works. So hopping back to the slides. So I was like looking at DockerCompose, I thought, oh, that seems like a pretty good way to build these service bus, to have them all talk to each other. Like we have a UI, we have a web service, we have MySQL, we have a CDB generator service that's syncing these containers. So conceptually, it seems like a good fit. They can spin them all up, they can all talk to each other. Maybe we want to use this. So after doing a little vetting, I came up with some requirements of my own requirements that I wanted for this solution to work for me. So one of the requirements was that developers must be able to use whatever host OS they want to, and use whatever IDE, whatever text editor, whatever debugging tools, things like that. So that was like a hard requirement. And then the other requirement was, even if that's the case, I believe the developers should be using running systems that are the same, within reason. Like maybe it's good if someone's using if your prod environments aren't exactly the same, maybe it's good if someone's running Go 1.10, somebody's running Go 1.12 for a while. Those kinds of things we do, and that's fine. But for the most part, like we have MySQL configurations, for example, where they're always the same. Like it doesn't matter, they're gonna have the same setup configuration. So I thought, I think it's important for, like I said, within reason, for developers to be using the same setup. It just helps with collaboration, bug reports coming in from prod, but also like developers finding bugs that maybe it's not even a bug if they're just have a quirky environment set up. So, and then feeling lightweight and unintrusive, and then having clear step-by-step instructions from start to start from scratch. I added that last one. So actually, I'm on my, so I can actually bring up this is our repo at Walmart. We have an internal GitHub enterprise. And this is our dev Docker files page. So before I unleashed this on everyone, like I said, one of my requirements for myself was that there was full step-by-step instructions, starting with installing DockerCompose to actually logging into our services. And this made it, and there's some caveats about if you're running Linux, you might want to do this. If you're running Mac, you might want to do this. I set up virtual machines so I could actually test it on Linux and Mac OS and make sure that it worked beginning to end, step one all the way down to the end. I felt that was really important for adoption because in the past, some people had used Vagrant at previous companies, and maybe my experience with Vagrant was just bad because it seemed to always be broken and I could never get it to run right. So I wanted to make sure that anyone could just follow these step-by-step instructions. So just skimming through here, there's a couple of interesting things we did at Walmart that might be worth pointing out. So we have a lot of IPs at Walmart, and one of the default Docker subnets conflicts with the internal Walmart subnet. So after diving in to a lot of GitHub issues and conversations, I found this neat little snippet here. Maybe it's unlikely that you'd ever need it, but it lets you specify which subnet you want to use for Docker. Another issue we ran into, like I said, Docker Desktop actually uses a hypervisor, and there's some, the defaults are pretty minimal. So if you're going to be running, a bigger system, there's some stuff you want to tweak here. Otherwise, you'll have a bad time. And then, yeah,
Show the composition stuff, because you can, since there are so many pieces, being able to bring up just the pieces you want.
yeah, definitely. Yeah, I'm gonna go in. Yeah, thanks. I'm gonna go into the. Let me hop back to the slides and see where we are. Yeah, so those are kind of the step-by-step instructions, and then yeah, finally I'll show you kind of what we arrived at, what our DockerCompose file looks at, some of the features of DockerCompose that we use I thought were maybe unique or super helpful. So we Docker files repo, I was just showing. Actually, I'll hop back to my correct tab here, window. Docker files. Our DockerCompose file is getting pretty big at this point. It's almost 300 lines of various services that we use. It's kind of trying to feel out of like when it might, because you can actually, in DockerCompose, you can specify multiple DockerCompose files. So kind of trying to feel out whether it makes sense to kind of break them into logical chunks at some point. And so it's not just one big wall of services, but this is where we are today. It's not really a big deal because of the composition, which is where Compose comes from. You can do with these, which I'll show you. Basically, DockerCompose composition means you don't have to run everything in the Compose file. It's very flexible in what you bring up, and you can specify, like for example here, NSQD depends on NSQ lookup. So if I bring up the NSQD service, it knows it also needs to bring up the NSQ lookup service, for example. So we use NSQ at Walmart, which is just a message queue. It's written in Go also. It's relatively lightweight compared to something like Kafka. So if you don't need like, if order isn't important or do messages or things like that, it's highly reliable and pretty quick, and it's relatively simple, relatively easy to maintain, I would say. NSQ admin, again, another depends. NSQ tail. Some people have stuck some kind of more, maybe, I don't know the right word, auxiliary services in here, and that's kind of what I've been thinking is maybe it makes sense to have like an aux DockerCompose file that has kind of the more like supporting things. But anyway, I guess what I'm getting at is some of these might not be super interesting, but etcd, Greg added that one actually, and nobody's touched it since he left. Okay, so MySQL is a big one that we use. So one of the neat things about DockerCompose that I wanted to talk about is kind of this syntax here for values. So yeah, this is like basically a key value or name and value. You're setting up. I'm setting up some environment variables for MySQL, like the root password, the database, the user, MySQL password, those things. So this syntax is really cool because basically what it's saying here is use this, well, how's the best way to express this? This is the default. Root is the default value. However, if it's written in this environment variable, it'll use that instead. So environment variables, DockerCompose kind of has its own lookup path, lookup order for environment variables. So if I go to my code, dev Docker files, you'll notice I have this .env file here. That's a DockerCompose specific thing where I can go in and set up all of these values that I want to be specific to my machine. For example, if I'm already running a MySQL instance for something else on my host that I want for whatever reason, I can go in and tweak this to whatever I want it to be. But average dev that doesn't care about like going in and configuring a bunch of things to set up his environment, he'll get sane defaults. And we found that to be really helpful, like more than you would think. Because it goes back to that thing about like in previous places I've been, these kind of canned development environments, they were always broken in some way and really frustrating, and I kind of just fell back to doing things myself. Kind of what you're doing here is providing things that'll work out of the box unless that person has some specific need to change them. So it's simple but efficient, and it's really nice that it's a feature in these DockerCompose files.
But that syntax also works to set default environment variables in Bash. The exact syntax. Prefix it with a colon.
So here's some volumes we were talking about. So I should probably just leave that environment file up there because I keep referring to that. But, so host, MySQL, we kind of use this host prefix to refer to things that are paths on, or paths or settings that are on the host versus the container. Those are the ones where you'll have conflicts, right? Because you might have, two MySQL data directories on your host. But hopefully in the container, we own that environment. So maybe I don't know. We do set a couple of container ones, but host is actually, looks like I only used host. So maybe it's a little redundant, but I guess it's just explicitly saying that, yeah, these are settings that affect the host. So for example, my host MySQL data dir is this path. If I go there, you'll see a gzipped SQL file. And the way we actually do that is we have I'm going to say like a QA environment. Like it's basically it's like a simplified prod environment that we actually deploy to, and other Walmart people actually use and have test applications for. So what I do to populate my local environment is I take a snapshot of that QA environment and I sync it. I put it out on a server, and then it will sync down. People can download and update it, and it'll basically populate your local development environment with sane, with data that's usable, instead of having to start from scratch every single time with setting up origins or servers or configurations. You kind of have what I do actually is I have my own test settings and plugins and redirects and all that stuff in QA. And I go put them there, and then they're kind of persistent. Every time I take a snapshot, they just stay out there. And then I have them on my local machine. So let's see. Admin D, that's our kind of front end. Well, it's actually our API layer. The control panel is our UI layer. But a lot of these things are similar. We have a couple of volumes, artifacts volumes that are shared build artifacts from our build system. And then what we do is we have a service that just starts up, downloads the artifacts that we want on multiple machines and puts them in this volume, and then they're shared across all the machines. So that's what we use our volumes for. Seems to work nicely.
Sure. No, then that's a really good use case. I'm saying there are places where it will set up volumes for you and even ask
Implicitly, yeah. And that's
volumes are a great thing. Absolutely use them, but it's nice when you use them.
So
building all of, so here's my question. I've done a lot of this, and I have no answer for this. I've done a lot of Docker development environments for scripting languages, where I've mounted the code through into the container, and they've been on engines that auto reload when the code changes, right? Because the script, a lot of those will just oh, you changed this part of the API, let me reload that part. How do you manage rebuilding your Go stuff and running it constantly as you're developing in your own? Because I don't know how to do that.
Yeah, that's a good question. So
there's some auto watcher.
Yeah.
Admin D has it.
Yeah, the admin D might be in the, so jumping ahead a little bit,
We can wait if you want.
Yeah.
That's
I'll show you how we're doing that. Let's see. I mean, I don't want to bore you too much just going through this file, but so ODND, this is the main service I work on. I'm familiar mostly with this service. So getting to your question, the first step was to actually expose the code on the container. So we do that in a volume. We have we have the host go path, which is again set in that, that's actually should get a default, but the host go path has to be set in your end file. It's set to like code, yeah, on go by default, and then source. And it mounts that to user local source on that container. So if I was to create an instance of this ODND container and do that Docker run TI, start a batch session to get on it, I would see my code exposed in user local source. I also appended this RO for read only. So in my opinion, I felt like it was important to kind of push, nudge the developer to be doing the development on his own box. There's a few reasons for that. It's because it's a little bit of split brain if you're like, I'm going to develop something on my box, but then I want to go tweak something on the Docker. And there's really not much reason for that. But also, we're trying to keep the Docker containers lean and quick. And so I don't want people trying to like add all their favorite text editors and all those various like a bunch of stuff to avoid basically container bloat. So kind of nudging the user to develop on their host machine.
How does that work with vendoring and your dependency tools? Do you expect all the devs run those on their own machine? Because my instinct was to put the vendoring tool inside of the development container so that I didn't have to have it locally. But then you couldn't do that.
I was hoping you wouldn't answer that.
Oh, I'm sorry.
Rewind.
Because our vendoring is a little bit sad still. So
You check it in.
yeah, but so that said, the team that I work on, I feel like I'm up here justifying why we do what we do. But
I'm just asking. What makes whatever we have to do to make it work. It's fine.
It's this team started before Go 1.0, so there wasn't really a vendoring story at all, and it's just been like this thing has always been on the back burner, and then like people started getting excited about. I can't remember what was before GoDep, but there was something before GoDep, and then there was GoDep, and now we're on Go modules. So we always just kind of let's do this thing. Oh, it's changing. Let's do that. Right, it's changing. So we haven't really tackled like how we want to do that yet. But basically, we just fork everything, put it in our vendor in our own repo, and we pull from it that way. But basically, for now, the developer is responsible for getting all their deps sorted out, which I think would be fixable either. I think it would still be fixable on the host, but I haven't had to tackle that problem.
That's I'm just curious. But like I said, my instinct would be like, Lotto have your dependency tools, but you can't run it. You could have a different container, mount the same folder with read access that had your dependency tools.
Yeah, that's right. Yeah, and this isn't a hard, like, this could go away someday when it made sense. Just for now, read only seemed like a way to kind of nudge, like I said, like, you should be doing your development on the host, basically. Let's see. So, okay, so this is kind of, again, getting up to your question about how we do the builds. Sorry, what was it specifically?
The auto builds, like, so kind of a smooth dev flow of not having to control C or rerun.
Oh, right, okay, yes. So there's a few things I do for that. And it actually, a couple of teams do it differently. But yeah, okay, great question. I like it. So I kind of invented this pattern of, I call them command scripts. And if you go into the command scripts directory, basically all of the services that are actually our custom logic, not just things like MySQL and NSQ that just that we don't, there's no custom code or anything, they just come up and they run it. We don't, not doing really anything with it. But for our services that we write, I have little Python scripts. I mean, these could have been Bash. I tend to.
No, if it gets this complicated, you won't.
That's what I said.
As soon as you need a raise, you want something else.
I tend to agree. I used to write start things like this out in Bash, and then I decided that Python's a pretty good scripting language for.
Well, you could put Python in the container so you get your perfect portability, which was always the thing you got out of Bash anyway.
So basically, what the pattern within these command scripts is we do some prep work, we install a binary, and we run the binary. And so let me find one that I actually pull up the admin D one. Yeah, so it has this live reload inside of it. I can't remember which tool it's running. I didn't set this up. It's live reload. Default is.
Start and live.
Sorry?
Search for start underscore and underscore live, one line down.
Oh yeah, sorry. Thank you. I was using Realize.
Yeah.
So it basically starts when it executes. So the way this is set up is dockerr-compose will tell. Go to admin D. User entry. Okay. Admin D. So dockerr-compose command basically tells the Docker file what to run. So it's kind of like taking that functionality, put run and your service or whatever in Docker file. And in dockerr-compose, you can overwrite that. So for here, we say by default, run this command script for admin D. So when admin D starts, it does a little bit of prep work, like creating some directories, really like quick setup things. Installs runs go install on the admin D code base for this service, and then it realizes, I'm sure installed on the Docker file, and then it executes realize. So realize is already in the image. So it runs realize, points it to the admin source right here, and the configuration, and then it will admin D, every time you modify the code, it will update and build. Cool. So that's one approach, and it seems to work well. That team uses that, and they seem to like it. I use a slightly different approach. So to show you my approach, and actually you'll see the admin D one also. But I'm gonna bring these up. I'm probably, I don't know how much time I have, but probably wrap up soon. Let's see. So sorry. Okay, so that's a terrible name, but dockerr-compose goes up, and then I just note, so this is the composition that Greg was talking about. So I don't want to run all those things. I don't care about a lot of the services that were in that file. In prod, they'll all be running and doing stuff, but for most of my day-to-day job, I only care about ODND and some services that are directly related to that. So I'll run something like up ODND. I know I need to run NSQ. This is actually a bug in my opinion. We shouldn't depend on this right now. And then NSQ CDB push. I need that to sync over my configuration files. Admin D control panel. And most teams I just encourage to create an alias. Like if you want to these services up, and this is your normal workflow, just create an alias, bring up the services you want. You'll be on your way. So, yeah, bring these up, fingers. Again, I already did all the builds, so I don't have to wait to pull down all of, Ubuntu and, Debian, Go, and that stuff. So you'll notice here, even though we have a dependency specified in dockerr-compose file, it doesn't actually wait for like MySQL to be able to have a socket open. It just says, oh, I need to bring up the service too. So I have some logic in our command scripts to actually do some waiting and check on the remote port for MySQL to come up. Admin D is the service. It's the API service, so all those API calls write data and read data from MySQL.
I think there's actually a benefit in the case of Docker files like this because it gets you to think about distributed systems as not being, because otherwise you get used to like, oh, this only works if we bring up MySQL first, and that is bad for fraud for all sorts of reasons.
Yeah, that's a good.
Used to like things are all up at once and ephemeral.
Yeah, I think that's a really good point. Some people were complaining about this at first and then trying to fix that. And some people were complaining about some error logs you get if one service comes up before another. And I was like, well, that's just wait. Like it'll hit a steady state, everything comes up and is happy. So
the problem is you don't want to delicate like bring up these things in this 10 order to make fraud work. Like.
So yeah, you'll see here this admin D started and it started this watching the files.
So if you go change code right now, it'll rebuild and reload. That's pretty cool.
How are we doing on time? Do we have?
It's 7:30. So if you want to go ahead and wrap up, take questions, that'd be about good.
Cool. So I'll just show you the one last thing of what I do for another service to kind of accomplish the same goal, and then we'll call it good.
I'm guessing realize is some.
I dropped a link to it in the Forge Go link.
Okay.
It's actually a task runner. It's a task runner, but it works really well for this. One key point too is these are not production grade containers. These are dev containers, right? Like these were designed for dev. You would not take these and throw them into a Kubernetes cluster. They were designed for this specific use case, which is something that's a little different. A lot of people try to take their prod containers and then like dev on them, and that just doesn't jive. So I think there's still any dev container, any actual prod containers at Walmart are generated by like a CI/CD pipeline. These were crafted specifically for
have tools to be like easier.
Yeah, so if you add in realize, it's like you're not taking a perfit, you're helping your developer.
Okay, so it takes a little bit to come up at first. It's a little bit of a downside. There's probably some optimizations we could do to do more things in parallel in the setup files. These are those errors I was talking about. But we're pretty close now. And then once they're up, you're generally only working on a service or two at the time, and you can bring those down and up individually, so you're not waiting for the whole system to come back up every time. Leave them running. You can Control-C and stop them and bring them up later on. But okay, so we're good. ODND is running. This is the guy I care about. It's getting CDDs, again, which are our configurations. So I can go into dev Docker files, my README. Okay, and again, my instructions at the very end, you should now be able to access a control panel. Almost.
Powers.
Just blame the Wi-Fi.
Yeah.
Guest Wi-Fi at Weave doesn't let you do all the secret stuff.
Actually, can't remember if I got a chance to test this today, but if this doesn't work, it's not a big deal. Okay, sure. Okay. So just copying my password there, and okay. So this is our UI. This is just a test config that I use. It points to my personal website on the back end. It has a bunch of stuff. I have redirects. One of the things we do in that big yellow box of all our features was HTTP redirects, which is one of the more simple things to show. So for example, I have this foo02 redirect that redirects to bar02. We do all kinds of cool things with redirects like flattening and cycle detection and things like that. But for the sake of time, just show you what a command looks like now. And I refer to our README a lot to just get addresses and things even still. So I'm actually running on port 80. I know that because I have my environment set up. I was using that to debug a specific issue, which is, again, the nice thing, the way it's configurable with that .env file. And I can do something like curl, -v -host. Test origin there. That means the proxy will go to that. And use that host. Yes, thank you. And then I can do that 202. And you'll see there's a 301 and it's straight directory. So that's all those things are happening. The UI is working. If I modified that, I'm not going to do this all the time, but if I modified that, it would call that API of admin D. That would sync out to MySQL. The CDB generator would read this MySQL, send the configuration to the proxy, and then it would get that updated value. And all that's just happening right here on my local machine. So the one question about how do we do this? So there's it's a bit of a hack. They could probably add a quick flag to be able to do this same thing. But what I do actually is I just get rid of the install ODND and the execute ODND, and I just do something like this check. This is just executing a shell command. I just do something silly like dev-f dev null. That'll bring it up and it'll spin forever. And then I just run docker ti, docker run ti to attach to it. I know where my source code is, cd to the source code, stop the service, run go install. All the paths and everything are all set up. I can just run go install, go test, whatever right there in a separate Docker window. Does that make sense? I can show it, but I think we're running.
Just injecting yourself into that and plugged in.
Yeah. Yeah. So I guess so to do that, I think this is important because this is a kind of a neat little trick. You can do a dockercompose down ODND. DockerCompose down. No, dockercompose down isn't the thing. DockerCompose stop for ODND. DockerCompose RM ODND just to be safe. I didn't do that. It comes up really quick enough. I made that change to do that thing. So I made that change in the Docker files. And then what I'll do is DockerCompose up. To bring it back up, it'll now run with that dev null thing. But I run a -d for detached. And then what it will do is start it back up, but you'll notice it popped back over into my log. Oh shoot, I screwed up my command here. Not dev. Hey. Yeah, and then it's there. Docker run ti. There's my image bin bash. Oops. Docker.
Yeah,
sorry,
run makes it container.
sorry, I'm panicking because I feel like I'm out of time. But
Still
We can
good.
leave if we want to leave.
yeah, you're trapped from the garage.
That'd be a fire hazard if the only door was a garage door.
I held this meeting up for like 3 hours once for a talk here.
So my source code on the Docker container is user's local source, tb odnd. I have my path set up, so when I run go install, it goes into the path. I can run go install there, installs a binary, and I can just run ODND that way. So I could go modify the ODND code, add a feature, do whatever, and then install it and test it easy like that. So you're running, I actually get my logs in my own window, which I kind of like. Our binary takes forever to install on the first time, but then some things get cached and it's much faster. But maybe even might be more interesting is like if I go into proxy hooks, I can do something like go test and run my unit test, for example. That's there. Yeah. Any questions? Anything else?
What about 5 minutes for questions if there are any?
How do you deal with configuration?
Of what?
Yeah, issue.
Oh, that's a great question, actually. So test run. I'll show you. So again, as part of this kind of DockerCompose files hierarchy, there's a config subdirectory. We have all of our configs that we want to use for dev in there. And then as part of the command scripts, part of what they do is, actually, no, it's not even true. Sometimes we have command configurations that are templates. And so the command script will actually come up and fill in the template based on some IPs of some other services and things like that. That's kind of the more complicated case. But the more simple case is in our DockerCompose, we just mount those config MySQL to their correct directories on the container.
With the different containers and like how they start up in order, like I like your idea better, but Docker also has the option to where you can set the state of a container so that when each starts up, you have health checks on each, and then you can start them up. You know, one will depend on another if it's healthy, and it won't start the second one until the first is healthy. So that's another.
And that might be like very like newer Compose features, because that was.
I think it is relatively new. We've tried using that and we had mixed results. It seemed like it worked. You're not running a Mac, so were you running those tests on a Mac?
It was on Linux.
Yeah, I had issues with that working on Linux, but it seemed to work on Mac. So maybe we just had a bad version, but that's a good point. You can set up health checks in DockerCompose. It'll abstract that for you.
So that's good, something to know. So check that if you go that way on Mac. Okay.
Yeah. Yeah. But no, I was having issues on Linux and success on a Mac. So it could have just been I just had got unlucky on a bad Compose version. But yeah, it's cool. That's a good thing to point out.
Probably not super great design in the long term, right? Like you should have your things be more resilient, but you have cases where you might need it.
Cool. Anything else? Okay.
Let's give them a